All right, so to begin chapter 1, we have this question regarding absolute values. It asks us to simplify. It says that x is between 6 and 7 and can't be equal to 6 or 7, and says this, and we have to simplify for a value. Now, the initial instinct would be to pick a number between 6 and 7, say 6.5, plug it in for both of them, and then test for it. But I'm not going to do that, and I'm going to do it the logic way, because doing it that way opens you up to errors where, like, something down the line says, like, don't do that, or it says explain your thinking, um, like, in regards to absolute values as opposed to just plugging numbers in. So, any number we plug in for this part of it here, any number we plug in here, I'm going to split this up into its two parts. Any number we plug in here, because it's going to be greater than 6, we'll leave it as positive inside the thing. So we know that we can technically just take away those absolute values. Plus, all right, now let's take this one. Any value we put in for x within these restraints is going to be less than -7. So that means that this will always spit out a negative answer. So we do the exact same thing over here, but now we include that negative sign because it'll always equal negative. And this one will always equal positive. So technically there's a positive sign over here. So now we just simplify. X minus 6 minus x plus 7, distribute that. X minus x is 0, so those cancel. -6 plus 7 is 1. That's our answer for number 1. Now, let's write down number 4. Number 4, oh no, it's a long chain. 1 over x, no, 1 minus x plus 4, 2 minus x is equal to 11 over 6, and we are asked to solve. All right. Gosh, this one's going to be a pain. So what we have to do is solve for x here. So our first step is we're going to change this into one fraction by finding a common denominator. So what we're going to do to find our common denominator is multiply this side by this denominator over itself, and then this side by this denominator over itself. So it's going to be 2 minus x over 2 minus x on this side, and 1 minus x over 1 minus x on this side. We have to multiply it by those things because if they're not over themselves, they're not equal to 1, which means that we'd have to change everything. And we can't change everything. Multiplying anything by 1 is just itself. So now we can get them together like we need to. So 1 times 2 minus x is 2 minus x over 1 minus x, 2 minus x. I'm not going to distribute that just yet because I may not need to. Plus 4 times 1 minus x over 1 minus x, 2 minus x. All right? Is all equal to 11 over 6. And then now we can combine all these together and also simplify this down. So 2 minus x plus 4 minus 4x, because we distribute that 4. So x times x is x squared. So we're going to have a negative x times 2, so negative 2x. We're going to have negative x times 1, negative 1x. Negative 1x plus negative 2x is negative 3x. 1 times 2 is 2 plus 2. I just FOILed it out. All right, and then simplify this down one step further by making this numerator a little bit more simple. Negative x minus 4x is negative 5x. 2 plus 4 is 6. X squared minus 3x plus 2 is equal to 11 over 6. Now, what we can do is we can cross multiply. So this, I'm going to use this color. Those multiply with that, and those multiply with that. And we're left with 11x squared minus 3x plus 2 is equal to 6 times negative 5x plus 6. Okay, simplify this all down. 11x squared minus 33x plus 22 is equal to negative 30x plus 36. And then now let's make this into a quadratic. We're going to add this 30x over and subtract this 36x over, or 36 over, because then that keeps our a positive. 11x squared, add 30x to that is minus 3x. 22, 36, 22 becomes negative 14 over 0. Simple subtraction here. I don't know why I couldn't spit that word out. All right. Now I can't simplify this down, so that's our first step for solving quadratics. Second step is, can I simplify it like this? And I'm going to say the answer is no, because I've done this one before. Actually, I've done this one before, and I know it can simplify like that. I lied. 11x and x. You know, because those are the only two things that can give you an 11. All right, so now what we need to do is we need to pick two numbers that multiply to 14 that give you a 3 when they're added together. So I'm going to pick plus 1 over here and then minus 14, just for sake. Now, we know that one of them has to be minus and one of them has to be plus, because if it weren't like that, then this would not be a negative sign. So 11 times 14 is way too much to give us just a 3, so our 14 has to be over here. Okay, well, first of all, a 14 minus 1 is 13 times 11, so that would actually be 3, because 14 plus 11, negative 11, is 3, but that's a positive, that would make a positive 3. We need a negative 3, so let's switch these signs. Positive, negative, okay, is all equal to 0. And then now we solve. So 11x minus 14 is equal to 0. X plus 1 is equal to 0. So x is equal to negative 1. And add this 14 over, we get 11x is equal to 14. X is equal to 14 over 11. So, in total, x is equal to 14 over 11 and negative 1. But first, let's see if any of these cancel domain-wise. So 1 minus negative 1 is 2. 2 minus negative 1 is 3. That one works out. Okay? 14 minus 11 isn't 1 or 2, so it all works out again. So our actual answer is this. All right. Now, let's move on to number 6. If you see, I'm skipping a few because there are some that are redundant or covering topics that should be simple, or they're not quite necessary because I talk about them more than once. All right. Solve for x, and a is not equal to CE. All right. Now, if you know, this looks kind of like our derivation problems in physics, which are often a pain. So, first of all, we need to isolate x. So, let's try to get x out of the denominator, 1, 2, let's get out of the denominator first before we think about anything else. Okay, let's multiply this whole thing by cx plus d. Cx plus d on both sides. On both sides. So, these would cancel out. We're left with just an ax plus b on one side. is equal to e cx plus d. This simplifies down. Ax plus b is equal to, I'm going to order this alphabetically, cex plus de. Okay? Now let's try to get all the x's on one side so we can reverse distribute them all out. Ax minus cex is equal to de minus b. Alright, now let's reverse distribute. X is equal to a minus ce equal to de minus b. Alright, let's divide out. Let's divide out our a minus ce. Those would cancel. X is equal to de minus b over a minus ce. And then that would be our total answer. And now it makes sense why they put this a isn't equal to ce, because if a was equal to ce, we would have a 0 in the denominator, and we can't have a 0 in the denominator. So, I mean, it makes sense why they would put that up there. If it could be equal to ce, then there's a possibility that x has no solution, and it's undefined. But with this, we know x is a solution like this. All right, now, let's move on to number 12. Number 12 states, there's actually 3 parts of number 12. We have 12a, which states y is equal to x to the third plus 5x. 12b is equal to y is equal to 3x plus 3 negative x. And 12c, which is y squared, is equal to 5x squared plus x. All right. Now, all of them are asking us to find, they're trying to tell us to test for 3 symmetries. So it wants to know the 3 symmetries. If you don't know the 3 symmetries, it would be x-axis, y-axis, and origin. So it flips over the x-axis, flips over the y-axis, flips over the origin. All right, so now we begin. So let's graph these. Let's try to graph all of these. So we know that 12a graphs like this. So our degree, we're going to look for our degree, we're going to look for our a, and we're going to look for our y-intercept, because these are things that would make this graph way easier to do. So our degree, we're not even going to care about the number, we're just going to care about if it's odd or even. Okay? Because that means that it will end there, or it'll go there or there. Those are what the end behaviors are. A is positive. So that means that it's going to be this one where it ends facing upwards. Our y-intercept is 0. So that means that this is the point it starts on. It goes up like this something, and then down like this something. Okay? And now, if you know anything, I need to draw this better because that was horrible. That's what it would look like. So, if you know anything about functions like this and have a positive a, the degree is odd, and there's no y-intercept, they have origin symmetry. You can flip them over the origin, which means that if you translate them like this, and then subsequently like this, they follow the same exact path. So, we know that this one has origin symmetry. Okay? Now, this one. This one looks complicated, but we're going to do a different strategy for each of these problems to solve for them. Okay? So, let's go like this. Let's create a table. We live in the day of age of tables. Let's grab a calculator for this one. I assume you probably won't be using a calculator. I'm not going to use the graph function on this calculator, just because that would defeat the purpose of even doing this thing. So let's try to do it without the calculator, but if we need it, we'll bring it out. Okay, so let's test with our basic numbers. -2, -1, 0, 1, and 2. I know that I can use these ones because you can plug anything into these x's and not get a domain restriction, so we're fine. Anyways, we're also testing for origin symmetry and y-axis symmetry, meaning it would be good to know negative numbers as well. So 3, let's start with 0, because that's the easiest one. So 3 to the 0th power is 1, and then 1 plus 3 to the -0, so 0, 1. 1 plus 1 is 2. Okay, so this starts at 2. All right, 3 to the -1 is, first of all, I'm going to write it all out. 1 plus 1 is equal to 2. This is 0. Let's go 1. Okay, now 1 is 3 plus -1, which would make it 1/3. So 1/3 is equal to 3 1/3. Okay? And then now let's do -1. Let's just reflect it over. So -1, that would be 1/3 plus -1 is +1. So 3 is also equal to 3 1/3. Okay? So let's just write these in. 3 1/3, 3 1/3. All right. And then now let's do our 2's. So 2. So 3 to the 2nd is 9, plus 3 to the -2nd, which is 1/9, is equal to 9 1/9. So -2, we can kind of just draw from this thing and know that it's the opposite of what it was. If you need to know why that is, I'll just explain really quickly. -2 power of 3 is 1/9. -2 power, so in other words 2, 3, 9, is equal to 9 1/9. All right. I don't need to simplify this down to improper fractions because I just don't need to. All right. So we know that what this looks like, it has a point here above the x-axis. It moves equally on both sides. So it's just a basic parabola. Somehow it's a basic parabola, but it is a basic parabola. And it's the same on both sides, regardless of how things work, because, I mean, we just watched it do it. So this flips over this axis, and that's our y-axis, so this has y-axis symmetry. Y-axis symmetry. Now, let's look at 12c. This one's probably the hardest one. So first of all, in order to even have a function, we need to have y to the power of 1 and a equal 1. So let's square root everything. So y is equal to square root of 5x squared plus x. So now we also know that square roots always have a positive and a negative. That's going to come in big handy later. So now let's create our graph again. All right. So what things can we plug in for this to get it to equal 0? Let's see. Well, I mean, 0 squared is 0 times 5 is 0 plus 0 is 0. So this has a 0. My dog is scratching at my door. Hey, I'm doing a lesson. Stop. Okay. 0, so that has that. And then we know that these types of functions move something like this. And then we also know there's a negative side, so we know it's going to also move like this. Okay? Now let's see if there's anything else, because I think there is. X, let's simplify this down. 5x plus 1. Now let's see if those have anything that can equal 0. We know that 0 is one of the things. We just figured it out as 0. And negative 1 over 5 as our thing. So 5x plus 1 is equal to 0. X is equal to negative 1. X is equal to negative 1 over 5. So negative 1 over 5 is also 1. Okay? And now if we have something that goes like that, if we grab a number that is greater in magnitude than negative 1 over 5, let's just say negative 1, let's see what we get. Just to see how things would progress on the opposite direction. 5, negative 1 squared minus 1 is 5 minus 1, so 4. So 4 rad, positive and negative, would be positive and negative 2. So things would go equally on this side as they do on this side. And so this would be what our graph looks like for this. So now, let's determine what kind of symmetry this has. Well, I mean, it flips over pretty well along our x-axis here. So this has x-axis symmetry. And those would be our Chapter 1 recap test solutions.